Hello, ninth grade. I am going to create this video to assist you when you are practicing your solving from today's lesson. So I'm going to start with the problems that I did not go through in class today. So starting with number 1, negative 8b squared minus 9b minus 7 equals 0. So here's your a, your b value, and your c value in the quadratic equation. Now, for the discriminant, we need the b squared subtract 4ac, what's under the radical in the quadratic formula. And that tells us if we have a real solution or not. And so d, in this case, will equal b squared will be 81, subtract 4 times negative 8 times negative 7. And when you do that calculation, we get square root of 81 subtract 224. And so this value, feel free to continue subtracting, is the square root of negative 143. Okay, so that discriminant is negative. And that's because negative 143 is less than 0, we have imaginary roots. So imaginary roots would be the reason for this one. Continuing with number 4, we have 3r squared plus r plus 1 equals 0. Well, the a is 3, b is 1, and c is also 1. So the discriminant is b squared minus 4ac. That's really what the discriminant is. Yes, in the quadratic formula, it's under the radical. So this notation was actually not needed. But when we look at this calculation, here we see 1 subtract 4 times 3 times 1. And we get, this would be negative 12, so negative 11. So again, this is less than 0, so we have imaginary roots. Now let's keep going with number 5. X squared equals 81. So that means when we take the square root of both sides, x is equal to 9 and negative 9. In number 7, this is where we will need to look at our new process. 3m squared, and that is plus 1 equals 151. When we subtract 1 on both sides, we get 3m squared equal to 150. Then dividing by 3 on both sides, we get m squared equals 50. Then to take the square root of both sides, we have m equal to the square root of 50, which is the same as the square root of 25 times 2. 25 times 2 is 50, but 25 is a perfect square. So I can simplify this as 5 times the square root of 2. But I also know that there are two solutions, so there's a positive and a negative of this. If you'd like to write it out more specifically, that is a positive 5 root 2 and a negative 5 root 2. Looking at 8 in a similar way, we have 6x squared subtract 5 is equal to negative 119. Well, when we add 5 to both sides, we get 6x squared is equal to negative 114. Then when we divide by 6, we get x squared is equal to negative 19. Well, we can take the square root of this, and we just know that it is going to have an imaginary number in it. And so x is equal to the positive and the negative of the square root of negative 1 times 19. Then we can break that square root of negative 1 separate from 19 and write it as I times the square root of 19. So this would be your final answer for number 8. In number 9, you're factoring. We have n squared plus 6n minus 7 equals 0. Because our leading coefficient is 1, we can just consider what two numbers multiply to that 1 times negative 7. So that's the A times C idea. But then we need to add up to that middle term of 6. And the only way to do it is using 1 and 7. But 7 has to be positive and 1 is negative. So our factored form is n minus 1 times n plus 7. And that tells us our solutions are 1 and negative 7. Oh my, that whole time I did that without you seeing it. Feel free to review the video. My apologies. Now let's take a look at the later set of the problems. In number 11, we're going to use our factoring method that we just learned today, the factoring by grouping. So the next step in this process is to consider what two numbers multiply to the A to C, and that's negative 45, 3 times negative 15, but then those same two numbers need to add up to negative 4. So they need to add to the B. And so thinking about values that will add up to, or multiply to 45, we have 3 and 15, 1 and 45. We also have 5 and 9. And if 9 is negative and the 5 is positive, then we have it added up to negative 4. These numbers, negative and 5, then become coefficients for the middle term. So we have 3m squared, subtract 9m, plus 5m, subtract 15 equals 0. Look for the greatest common factor. Of these first groupings, we have 3m, and when we factor out 3m, we're left with m subtract 3. But over here, between these two groups, or this group, the common factor is 5. So we divide out 5, and we're left with m subtract 3. Remember that this is your greatest common factor of the groups. So m minus 3 times 3m plus 5 equals 0 is our factored form. And our final answers will be a positive 3 and a negative 5/3. Let's look at 13 the same way. In 13, we have 3k squared minus 8k plus 5 equals 0. Well, looking at what is A times C, we get 15, and then we're adding up to that B, which is -8. That would be 3 and 5. So -3 and -5 become the middle term factors. So we have 3k squared minus 3k minus 5k, oops, 5k, and then plus 5 equals 0. Notice this first group has a common factor of 3k, and then we have k minus 1 left behind. Then amongst the second group, we have -5 as a common factor. And when we divide out the -5 of each term, we have x minus 1, and that equals 0. Sorry, this space is close. From here, factored form becomes 3k minus 5 times that common factor amongst the groups. And we're left with k is equal to 5/3 and a +1. Thank you for watching the video.